Hello, Globebusters. Yes, of course they're serious. You do? You have? No kidding. Uh-huh. Oh, they'll cure your globitis this week. Thank you. We got one!
Ladies and gentlemen,
it's the Globebusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
And now, here's your host.
And welcome everybody to Globebusters, Light and EM Radiation. EM, of course, meaning electromagnetic radiation. I am your host, Bob, Xanadude60. And here we are back on another Wednesday evening, at least here on the East Coast. It's 6 p.m. And we're going to talk about the lights in the sky tonight. And, the more I think about, what NASA tells us about these absolutely preposterous distances that, light is supposedly able to travel, it's just ridiculous. It really is. I mean, light, of all things, out of all the EM types of electromagnetic radiation, is right at the top of the scale for propagation loss. Meaning, if you wanted to compare the same power of a light to a radio wave, the light would go far, far less distance through the atmosphere, or even through a vacuum, whatever, it doesn't really matter, than any other EM radiation, especially like when you're comparing, radios and stuff like that. And I'll be talking about that, but it's just crazy. And what brought it up was I got a EM or a Skype message from a buddy in FE Core, Sandor, and he said, "Hey, did you know that Mr. Thrive and Survive was talking about your presentation that you did years ago," and it was years ago too, it was like 5 years ago, about the path losses to the moon, right? And I go, "No, I didn't know that." So I went and I checked it out, and sure enough, somebody had actually mirrored that video, or at least that section of it. And, the trolls again were all over it and say, "Oh, this guy doesn't know what he's talking about," but that's always what they say. But, of course, because, we don't see things the same way. Obviously, we're crazy. We're not capable of critical thought. We certainly don't have any education, right? I mean, heaven forbid. And I think the thing that really gets to them is, I was an RF engineer for years. And, that's what I did for a living. I was a field engineer. Absolutely loved it. One of my favorite jobs ever, working out there on microwave and satellite stuff, believe it or not. And was on the downlink side of it. But in the Air Force, I was a radar technician. And, at the age of 17, I had a first class commercial radio telephone with broadcast endorsement, radar endorsement, all this stuff. So, I mean, I was like major into RF, in general. Of course, being a ham radio operator was the biggest part of that, because my dad was a ham and my mom was a ham, and just about everyone in my family are ham radio operators. So I came by it honestly, but it is amazing, because they think that, most people can just go around and say, well, just ask any ham radio operator about them, being able to bounce signals off the moon. And it's like, well, the problem with that is not all ham radio operators do that. And, I have yet to see anybody come forward and show me exactly, how they're doing this. Because from what I've read about it, it almost seems like there is an element of the internet involved. Now, obviously the internet wasn't around years and years and years ago, but, if these guys are actually bouncing something off what they think is the moon, then I would also want to see something like, well, how exactly are they timing it? To get the exact time back, signal out, time back, et cetera, et cetera, et cetera. All of this stuff seems to be just hearsay. I have yet to hear anything about it. Now, as far as can the signals bounce off of stuff? Well, I would say absolutely yes. In fact, the firmament seems to have very different, altitudes. If it is in fact dome shaped, then there's going to be different altitudes to it. If it is partially liquid and then actually gets into a solid form, then the viscosity may have something to do with it. I don't know, but I do know that when you start changing mediums like that, you also start changing propagation times. So that to me does not put it outside the realm of, some other explanation being able to be made. But like I said, so far, I have yet to see any ham radio operator come forward, and I've put this call out many times for them to show me how it's done and, exactly how they're receiving it. But, and I'm still going to keep trying, believe me. And if any of you guys know anybody that's doing this, hook us up. I would certainly love to do that. But anyway, all right, so that's just a little bit of an overview on what we're going to be doing today. So let me go ahead and introduce the panel. And first up, we have John the Morgile. How you doing today, John?
Doing very well, Bob. Hello, everybody. Hello. Looking forward to another great show today.
Awesome. Very cool. All right. And next up, we have Mr. Zachary Zabala, or also known as Good Times for All. How you doing today, Zach?
Hey, Bob. Pretty good. Hello, everyone. Yeah, weather's finally broke. We got some 80-degree weather around there. And, I can finally work outside and not just start sweating instantly within 10 seconds of moving.
Yeah.
So it's nice.
Yeah, no doubt. Yeah, it is brutal. I mean, and it's weird because you can be in the middle of the day and it can be kind of cool. And then in the evening, it actually warms up and gets muggier here. So, still trying to get used to the weather in the South down here in South Carolina, but I don't know if I ever will, but I sure do think it's pretty down here.
Yeah, for sure. Absolutely.
Yep. All right. And next up we have with us Mr. John Savage. How you doing today, John?
Hey, Bob. Hey, Zach. Hey, John. Doing really well. Speaking of ham radio, I'm just in the process of setting up my rig again since I've moved my battle bus and all that sort of thing. So looking forward to getting back on the waves. And weather's all right over here. I'm quite excited today, actually, about the Alberta in Canada, of all places. A court got it on record that the government does not have any material evidence proving that the virus even exists. So that's actually, I think it's the first time it's gone on the court record. We've had FOIA requests for sure from numerous governments, but yeah, that could be a game changer for sure. But in the meantime, looking forward to the show.
Yeah, absolutely. And we'll probably talk about that more on a Sunday show when we're not, when we're exclusively on Rockfin. But yeah, I saw that, and the Canadians are very, very happy about it, obviously, and you can't blame them. So that is good news. And
yeah, but their bacon still sucks. I'm just saying.
Yeah, no doubt. So, oh well. So, John, have you ever worked EME bounce, or do you know anybody that has ever done EME bounce?
I know people who claim to. I don't know anyone personally. I know people who do it. And like you say, there seems to be a lot of software involved with it. It's like my mate taking a picture of Mars, where he doesn't even have an eyepiece, and his telescope takes 1,000 pictures, and they overlay it over each other, and then popped out the other end and says, here's your picture of Mars. That's what I've heard about it. But I'll put the word out to a few of the ham friends we've got over here and see if anyone is actually involved in that. I know a microwave ham radio expert over here who I was trying to get involved with FE Core. But yeah, I might put the word out and see. I'll be interested in what you're going to show us here today, though.
Yeah, well, that's the whole thing. And like I said, I don't believe for 1 second, their whole story about even sending anything out to the moon, because first of all, the hams are limited. And this was the reason I did this presentation 5 years ago, was, primarily, lighting up on that. But the hams are limited to 2,000 watts peak envelope power, at least in the United States. I don't know if it's different in other places around the world, but and then you can send that to your final amplifier, and then whatever your gain of your antenna is. And I looked at that, and I was looking at these frequencies, and I guess they're doing it in the 2 meter and 450 band. Is that correct?
I'm not entirely sure, but I know the over here with a full license, you're allowed 100 watts.
Wow, really?
Pathetic. Most of Europe is allowed 1.5 kilowatts, I think. But yeah, here you have to apply for another license to get anything above 100 watts.
Wow, that's crazy. Oh well.
Sort of limits our reach, really, doesn't it? But like you say, if the world is spinning and the moon is spinning and everything else, how is this thing even coming back to us? It just does not add up. I'm sorry.
Well, real quick about that 100 watts. Is there a way for somebody on the receiving end to know how many watts you're using?
No.
And 100 watts. I mean, yeah, a lot of the equipment you can get can go a lot higher than that. But of course, none of us would ever go above our license parameters.
No, heaven forbid.
No.
That's like asking C beers in the United States to stay in their 5 watts. Because I remember when I was a kid, CB was all the rage, and everybody's running these 100 watt, 250 watt amplifiers. They were called afterburners, for the CB band. And of course, at that time, because CB is 11 meters or 27 megahertz, which is really close to the ham 10 meter band, is 28 megahertz. The propagation would get pretty good, and you'd be amazed. You could work all kinds of places with it.
Yeah.
So, but boy, do I have a different viewpoint on, how it all works today. Because when we're talking about propagation, it obviously, now I understand fully that the curvature of the Earth does not exist. Therefore, these propagations, these long trip propagations are making it their straight line, right? Or if they are bouncing off of something, it's likely something like the firmament. Again, we don't know because they don't give us a lot of data on this. But, they can bounce all kinds of weird stuff off of the firmament. Most specifically the yellow band laser that they seem to create these artificial stars with. And I wouldn't say that's necessarily bouncing it, but obviously it's hitting something there that is tangible, right? So, that tells me that there's something there. And for it to be right at that 100 kilometer mark or 62 miles, it's like, yeah, all right, that's starting to sound a whole lot like, the firmament, and, a lot of things happen in that particular zone too, right? Because
it's far more doable, isn't it, at those sort of distances that we're talking about? But also, if it is, if it's how we think it is, and I'm sure it is, then with enough equipment, hams, etc., we could actually map the geometry of the dome, surely, or whatever it's bouncing off by somehow. You could map that, couldn't you?
Yeah, absolutely. Well, you should theoretically be able to see it with some sort of radar, right? And that's something that we couldn't raise the radar that high when I was in the Air Force, but even if we did, I'm not exactly sure if the 2 gigahertz band would cut it, or if it would have to be in a different microwave band. But theoretically,
is that why they? Oh, sorry, Bob.
No, go ahead.
I was just going to ask, is that why they don't allow radar operators? Because I've heard multiple radar operators say that they could turn their instruments way up higher than they go, but they have to keep it within so many miles of the tower there. And yeah, they say that they run at a very low amount of power compared to what they could.
Yeah, absolutely. Because one thing we know for sure, I mean, even when I was in the Air Force, we were able to track aircraft, 100 miles away, all the way down virtually to the ground at an airport 100 miles away. And of course, did I think about anything being amiss at that point? Nope, I sure didn't. But 100 miles away, it should have been below 6,700 feet of curvature, right? It's like,
Yeah, and my air traffic control Globy friend confirms that as well.
Yeah. And this was, back when I was in the Air Force in 1978, boy, they had some old stuff, FPN 47, MPN 13. I mean, it was like vintage, 60s type stuff, 50s and 60s type of stuff they were still using. Why? Because it still worked, right?
Probably works better than the stuff we have today. The way it's going, vowels and things worked fantastically, didn't they?
It might, who knows? But, they didn't seem to be putting a whole lot of money into new equipment at that point in time. So, I don't know. And you see that in general with the military. I think unless you're in the absolute upper top echelon, with the military, you don't get the latest cutting edge, type of stuff. I mean, they don't even give the military guys, adequate protection, honestly, for being out in war conditions. So, why?
They're too busy pilfering it for their own pockets, aren't they?
Exactly. Yeah, they really are. And it's pretty pathetic, that they do that. But so anyway, understanding what I know about it now is that, this so-called over-the-horizon radar absolutely is not going over the horizon because, technically there is no horizon, to speak of, because the general terrain is flat. And of course, these over-the-horizon radars are also set up fairly high, right? And that gives a decent clearance to the ground for Fresnel type clearances. And we've talked about Fresnel on this show before. The Fresnel zone basically keeps you high enough off the ground so that if the signal bounces off of any objects on the ground and it bounces up, and then what will happen is it will come into the receiver at a little bit different times, a little bit different phase, and it'll cause all kinds of problems with digital and analog communication, et cetera, et cetera, et cetera, right? But as far as, once you get away from the Fresnel zone and you're clear of that, then really the sky's the limit, more or less. And when you think about like what it takes power-wise to broadcast, certain distances, we're all familiar with our AM radios, right? And, I actually haven't listened to AM radio in quite a while, but back in the day when I did, you could probably notice that if you tuned in at night, you could pick up like clear channel radio stations, which were 50,000 watts. We had one in Denver, KOA, 50,000 watts, and it Colorado is it's a little bit to the west of center, and of course the antenna is being broadcast off of Squaw Mountain, which is 11,000 foot above, 11,000 foot up on Squaw Mountain. And so it's got a really good shot. So when nighttime comes and they're still running that 50 kilowatts, then, and the noise floor drops a little bit, then you can actually hear that radio station 1,000, 2,000 plus miles away, right? But that's running at 50,000 watts, from the broadcast source. That's a lot of power.
On the opposite end of that, the experiments I was doing last year with using the Whisper network, I was transmitting at 0.2 watts, and I was heard in Antarctica.
Yeah, and that.
How mad is that?
I think that has to do with these plasma tubes that is discovered. In fact, John has talked about these several times. But there are absolutely these plasma tubes, and they seem to be running along the ley lines, right? Especially up the East Coast and places like that. A lot of ham radio operators that are into QRP or low power They have discovered that going up this 188 ley line, I believe, which runs up basically the East Coast, I think I'm pretty close to it here, honestly, that they can get away with using really low power because for whatever reason, the signal will get caught in these conduits, these plasma conduits, and they will migrate, thousands, hundreds and thousands of miles. It's crazy. So
well, that too, and the fact that I'm on the south coast of England, and there is no land between us and Antarctica, according to the maps that we know.
What about on the flat Earth map? I don't have my FE map here.
Yeah, I think it's a straight shot again, straight down the Atlantic.
Yeah. And I've worked, when in Colorado, I used to work KC4 AAA, KC4 AAC several times. Got all kinds of QSL cards from them, the Edmonton Scott station, and I can't remember all the other stations, but, I worked a bunch of them.
Yeah.
But in general, the theory that they teach you is that, what it's doing is the signal is going up after it transmits, it bounces off the ionosphere, which is something that was kind of coincidentally invented afterwards, after they figured out, oh my God, these are going way too far, much further than what they thought they would go. I think it was Marconi or something like that when he set up his broadcasts on the East Coast. They heard it all the way from the UK to Hawaii, right? It's like, whoops, that's a problem, isn't it?
I think there was some reported going from like New York to Australia as well, wasn't it?
Yeah. Yep. I'm sorry, Zach. Go ahead.
I was just saying, you were at night. The AM radio travels further. Why is that? Something to do with the light, the illuminated ether above, or why is that?
At this point, I hesitate to believe anything the mainstream says about that because it's all fabricated to make excuses for an alleged curvature, right? But I think what's happening is that when the sun goes away, that you just get a much, much lower noise floor, and therefore the signal to noise ratio, drops considerably, or I should say increases considerably because the noise floor drops. And you are able to hear that signal much further away because the sun literally has gone out. And of course, the sun itself generates a lot of EM radiation, right? It's a broadband EM source. So that would be my guess as to what's causing it.
Right. Like if you're in a crowded, say, train station, you're not going to hear somebody whispering to one another, 10 feet away, but if the same train station is empty, you could probably hear that person whispering from the other side of the room. It's just a lot less noise, right?
That is an excellent analogy. An excellent analogy. That's exactly right. So you take away the noise and you can get away with that. And that's why, I laugh at things like when, the NASA chief engineer for Voyager comes on and says, yeah, we got Voyager broadcasting at about the same power of a refrigerator light bulb, which is about 25 watts from 3 billion, miles away. And, when it comes in, it's 1/10 trillionth of a billionth of a watt. And of course, a billionth of a watt would be a picowatt, 10 to the negative ninth, right? And then 1/10 trillionth of that. So, it's like these numbers are so incredibly ridiculous that there's no way they could pull it out of the noise floor, right? Because those noise floors are much higher.
Can they demonstrate that? Like, use a picowatt to put out a frequency and pick it up on this magical receiver they say they have? Can a receiver pick up a picowatt?
Typically, no. I've never seen anything. I've seen them spec'd in the microwatts, but never a picowatt. But again, we're just talking about not just a picowatt, right? But we're talking about 1/10 trillionth of a picowatt, right? That's just freaking absurd, man. We're so many orders of magnitude away from being able to detect that level of signal sensitivity. It's just nonsense, right?
We just have to take their word for it. That's all.
Yeah. Well, we really don't. All we have to do is apply some critical thought to it. And, anybody that's in the field, and I would invite any RF engineer out there, this is true. What I'm saying is true. We don't have the capability to receive these type of low-level signals. And therefore, when you start looking at the possibility of a 25 watt signal being broadcast in the microwave band for 3 billion miles, and what that comes in at, and they said it themselves, 1 trillion. I haven't even done the math, but let's just accept what they say. 1/10 trillionth of a billionth of a watt. Come on, guys. That's absurd. It just is. So, I don't know. But that's just another thing that you talk about. So, and the thing about it is like, when you get into any type of electromagnetic radiation, the higher you go in frequency, the more power it takes to propel that signal, right? And the reason, and not only that, but also the losses become considerably higher as you go up in those frequencies. So if we look at, for example, let's look at this Loran here, right? I just said, what are the Loran frequencies? And it says Loran A use frequencies between 1.85 and 1.95 megahertz, right? Well, that's pretty low frequencies. That's like 160 meters or something like that. It's way down there. And then they have some of them at 100 kilohertz. The free channel, you have the AM band, which is like basically 63 kilohertz to 1.6 megahertz, very, very low frequencies in the AM bands and stuff like that. But when you get into microwave, if you don't have some sort of a specialized loss or something to carry that signal to reduce the loss, for example, if you were to look at a broadcast station of a TV, right, and they're broadcasting at several thousand watts, thousands and thousands of watts, and some are just 5,000 watts, but they go up from there, and you were to compare that, and you were to run a cable TV network, well, obviously, because you are putting it through a cable network or something that is very low loss, like the cable itself, the copper, which is conducting the electromagnetic wave, then the loss goes way down, compared to what it would be in free space, right? So in other words, I can take a signal, and I can, with relatively low power, I can transmit that signal all over the place for hundreds, if not thousands of miles, for a budget of, probably less than 100 watts, right? But if I take that same signal and I broadcast it over free space, over the airwaves, the antenna, right, through the ether, then the loss becomes considerably higher. Why is that? Well, because the medium that it's going through is not highly conducive to electromagnetic conduction, right? It will conduct it. It does conduct it, but it's very, very lossy, right? Same thing with like light waves. Okay, so light waves, they have something that's called fiber optic cables, and that's where a lot of the high-speed internet is coming from today, right? So you have these pulses of light that are generated, on a coherent light source that are being pulsed down a fiber optic network. And again, as far as light power, it takes a very, very low level of light, probably less than 1 watt, to travel a long, long, long ways on this, type of network. But again, if you take that laser, that same type of light pulse, and you put it through free space or even a vacuum, right? Because NASA would have you believe that because there's no atmosphere out there, that you would be able to broadcast literally forever, right? And actually make these trips of 3 billion miles or anything like that. So my main point here is that out of all the electromagnetic frequencies, light is unquestionably the most lossy, right? When you actually start looking at the spectrum. And yet NASA wants us to believe that we're seeing light at light years away, right? Billions and trillions of miles away. It's like, wow, what kind of power is that really, being put out at? So that's, kind of what I wanted to look at, today and talk about that. So,
real quick, back to the receivers real quick.
Okay.
Do you know if any of those receivers have You know how our buddy A. McKinsey down there in Florida connected the mercury fluorescent bulb or the mercury bulb to his antenna
Mm-hmm.
and was able to pick up more channels? Do they apply that to our tech?
Not that I'm aware of. That in fact, that was the first time I had ever seen that was in the Iwaranon videos. I'm looking at that, and you guys, if you remember, if you saw the Iwaranon videos, there was one section in there where the guy took a little bit of mercury and put it inside of a small container and then literally just soldered it right on to a piece of coax that then went into a receiver, right? And I'm looking at that going, well, that's just silly. What the hell is that supposed to do, right? And apparently it acts as a very high gain signal accumulator. How it does it, I don't know. Like I said, I've never heard of anybody or seen anybody doing that. And then, Zack has this friend, Adam, that actually tried it and it works. And it's like, okay, well, I don't even know what to say about that, but
Now that needs testing, without a doubt.
yeah, it does. Because that's extremely interesting. So maybe, we should try something like that because, I mean, it's so utterly simple. It's just hard to believe, but I have no doubt, that Adam did that. Adam's a pretty stand-up guy and everything. And, the fact that he did that, I would be giving it a lot less credibility than I do now. So there's so much that they haven't taught us about that. Or maybe it's that type of receiver that allows them to pull a 1/10 trillionth of a billionth of a watt signal out of the mud. But I doubt it.
Yeah. How do we even try that? That'd be interesting.
Yeah, exactly. So anyway, all right. So I was looking at these Loran frequencies. And of course, Loran, what that is they take these towers and they set them right on the coast, right on the edge of the ocean. And they usually will separate those towers a couple 100 miles apart. Well, first of all, when you're talking about a couple 100 miles apart, you're talking about 3, 4, or 5 miles of curvature that's going to separate them, right? And for some reason, inexplicably, the Loran frequencies at those low frequencies now just follow the curvature of the Earth, right? And it doesn't seem to bother the timing or anything like that. So, and they just want us to believe that all of a sudden, what does it pull? What's pulling it down? Gravity? I don't know. It doesn't make any sense that it would do that. So
Ducting, Bob. Ducting.
Yeah, ducting, on the ground ducting type of stuff. So you look at stuff like that, the Loran, okay, great. That's a technology that is still in use today. In fact, I think that's where a lot of our so-called GPS actually does come from, because unless you are actually within one of the sites of these transmitters, you're really not going to be getting any GPS, because the GPS clearly doesn't work. I mean, they admit straight up that GPS. Now, this is another thing that's really weird. If you can go out and watch certain videos on Antarctica, and some people will say, oh yeah, the GPS works in Antarctica. And then other people will go down there and show you that, the GPS does not work in Antarctica. Now, I would tend to think that if we were truly on a globe and we had all these satellites that were, orbiting around, that somehow we would almost have to have GPS down there. But there is incredibly very little evidence of that, right? So, got to wonder about that. But
yeah, I wish I would have made a video. I was out in New Mexico, not even in a mountain. It was near going up the eastern side of New Mexico, nothing out there. Next town was 80 miles away. One of those types of things, near the Maxwell National Reserve up there. And I was not getting a GPS signal. There wasn't a cloud in the sky, not a mountain range anywhere around. I was just out in the middle of nowhere. And I had a Magellan GPS, which claims to be connecting two satellites. It's not, It wasn't on my phone or anything like that. It's an actual Magellan. And signal not found, signal not found. That's all it kept saying until I got closer to the actual reserve, and then it picked up.
Well, it's the same with Aussie Rob, talking about when he was driving trucks in Australia with that they were given satellite telephones, and he said, 200 miles inland didn't work, never worked, and that was just a known thing. So yeah,
and that's why
I think
we
know why.
We have these massive networks, and cell phone. One of the things I also used to do is build cell sites for a company called Cellular One. I was a field engineer that, I built cell sites, and so I understand very definitely how they work. And they basically just use these low angle of radiation antennas and when you see the sites, you can see that they have multiple arrays going around a full 360 degrees, and basically they make a honeycomb, right? And so when you're driving along, using your GPS or using your cell phone, what's actually happening there is the cell sites are keeping track of your signal. And as you get further away from one cell site and closer to another, well, then there's a voting mechanism inside of these cell sites that says, okay, it's getting weak here, you're getting stronger there. Looks like we're going to hand over the traffic, and bam, it makes a synchronous handover. And then you are on the next cell site, and it transfers the call to that. And you hear a momentary interruption, and you're off and running again, right? Well, this is how.
Hence why they're called cell phones.
Exactly. Hence why they're called cell phones. Exactly. So, in other words, you don't have these infinite ranges with anything, RF wise, not in electromagnetic radiation, RF, AM radio, and certainly not light, not by any means. Now, as far as gamma radiation and X-ray, I know that they have a very limited, area that they are also, and that stands to reason, right? Because they're even above the visible light spectrum. So anyway, one thing we do know that seems to help light propagation, at least on our Earth, is the magnification that is provided by the atmosphere. But the first thing you have to do is you have to understand the two different schools of thought on, what's going on with the atmosphere in the flat Earth model versus the ball Earth model. The ball Earth model basically says that the light that's coming in from the sun hits the atmosphere and then it scatters, right? And you have the scattering effect, and it scatters, and that's what gives you your blue sky, right? Because of your wavelengths and stuff like that. Whereas the flat Earth model is very different. The flat Earth model is saying that no, we are in an enclosed system, and what is actually happening is the light noble gases, which are up at the top of the dome, or up near the top of the firmament, are actually fluorescing in the presence of the electromagnetic field of the sun. And the way that you can tell that that is absolutely true is by looking at the localized sunrise and sunset. In other words, now I'm actually going to play a video here by Dan Dimension. And this guy, of course, if you don't know, Dan Dimension is, you've been under a rock or something. But I'm going to go ahead and just play this really quick. But this particular video is talking about, the daylight. And when you watch the sun set against, anywhere on the flat Earth, especially if you're up high looking down, essentially what's happening is you are seeing it when it goes down below the horizon. You're seeing this very small area of the horizon that's lit, right? Yet, when we look at the ISS and how it supposedly, when the sun goes down below the horizon, you see all the entire half of the Earth evenly lit all the way across for 180 out of 360 degrees, right? Do I have to show you that? I hope I don't, but I certainly can, because that's exactly how NASA portrays it. And you know what? If the sun was 93 million miles away, that's exactly what we would see. But we don't. Instead, what we do see is this. So we're sitting here looking at a sun that's going away. It's not scattering, it's not refracting, nothing like that. And when it gets further away, you can tell that the light around it is very, very localized and limited to maybe just a couple of degrees across the horizon. Well, wait a minute. There's something seriously wrong with that. That should be literally, we should see this sunlight all the way across as far as we can see, to our west on sunsets and to our east on sunrises, we should absolutely see the sun all the way across those boundaries. Do we? Not a chance. Not a chance. So that's a huge problem.
I've never thought of it like that.
Right, I know, it's a dead giveaway, right? I mean, it's like right there, right in front of you. All you have to do is put it together, and like I said, if it's localized, it's going to be in a small area, and that's exactly what we do see. But if it was, and if I go to the ISS, I don't know, let's see if I can find an ISS feed really quick. Let's just see. Let's see, ISS. Live video.
Yeah, is this the one where he shows all the different gases in the jars and stuff in the test tubes?
It's one of them. I don't know. Yeah, I'll actually play that video. So let's look at this. Let's go around here. Now this is just them clowning around on a spacewalk. This isn't showing any sunrise or sunset. I'll have to see if I can find it here. Okay, here we go. So, Earth views from space is seen from the ISS. So here we have the sun, and basically when this is showing this way, we're seeing on their CGI, we're seeing that sunlight, oh come on, man, go all the way across, right? All the way across, just like we should see it, and not necessarily be localized like we do see it, right? So that's a huge problem. Okay, so let's go back to Dan Dimension, and I'm going to go ahead. I'm just going to go ahead and play a few minutes of this. Actually, I think it's music. Let's see. Yeah, it is. So okay, so I guess we can just let that play in the background. So what he's talking about is this is just a density tower, and we've got the lighter gases or the noble gases like neon and argon and helium and hydrogen, etc., that go up, right? So when we are watching these things, what's happening is when they meet the presence of an electrostatic field, right? It illuminates those gases. And not only does it illuminate them, but depending on the intensity and the angle that it meets those gases and fluoresces them, it does it in such a way that it comes out with the exact colors that we see at sunrise and sunset. The beautiful yellows, the oranges, the reds, the blues, and occasional greens type of stuff. All of this stuff right here, we're seeing this. Okay, and he's also saying that methane and monatomic oxygen is also a nice fuel measure. A fuel gas, right? That it can be used. I don't know exactly how that would work, but
and this would explain why we see daylight before we see sunlight.
Absolutely.
So if you're up at 4 or 5 o'clock in the morning, and you can see that the light spreads everywhere. I mean, even something that has its wall away from the rising sun is lit up. When I saw this video, it just clicked. You know what I mean?
Mm-hmm. Yeah, absolutely. And that's exactly what's happening. And so that's why we see the sky light up before we see the sun rise. Of course, the powers that be, the mainstream model dictates that what's happening there is the sunlight is refracting up and around, right? And being refracted and scattered all over the place. And that's just nonsense. But in fact, what we are seeing, and like I said, we see it perfectly right down to the exact colors of how these gases fluoresce. Look at this. This is neon, right?
That was amazing.
And neon, of course, will fluoresce from the least amount of energy furthest away. And those are the pretty, beautiful sunrise and sunset colors that we see. And here's their spectroanalysis, I guess. I mean, this is so airtight, guys. Pardon the pun, but this is so airtight that I don't see how the globe proponents have any response to this whatsoever. I mean, all of it is here.
They just won't look at it. Simply.
Yeah. They can't demonstrate
it. You guys don't understand physics or any of that. That's what it is.
Yeah. So tanning beds use argon. Argon is used as a shielding gas in welding. And then look at this. See, look at this localized field, right? That's localized because the sun is close, right? It's a high proximity. It is not lighting up in 50% of the sphere at once, and it just doesn't happen that way. But ironically, when you look, and I probably should have had more videos available, but I can pull up a million NASA videos that will show every time the ISS is going around and shows that sunset that sun lights up the entire horizon, 180 degrees across. You guys have seen it. We know it's there. Okay.
Well, it has to be, doesn't it? But none of us can actually see it personally.
Yeah, exactly. That's the way that it must work in the heliocentric model. Unfortunately, it does not work that way at all. So that's a big problem. All right, so now they're telling us, so I'm trying to figure out exactly what their angle is, with videos like this, right? No human has ever left the Earth's atmosphere, and here's why. So I'm going to play this thing. I want you guys to listen to what they say, and let's see if we can't maybe figure out why they're trying to take us here, right? Where they're trying to lead the narrative with this. So let's go with this. And this is for fair use and commentary, education, critique, yada, yada, yada. Here we go.
We've debated where the Earth's atmosphere ends.
Oops.
And through the history of space exploration so far, we've debated where the Earth's atmosphere ends and space begins. And your surprise for the day is that according to newly unearthed observations, our atmosphere is way bigger than we ever thought. Like, it goes past the moon. We've mostly defined space as the vast expanse of the rest of the universe that exists past the Kármán line, which exists roughly 100 kilometers above mean sea level. Now, according to the Fédération Aéronautique Internationale, the organization officially in charge of determining these kinds of rules, after the Kármán line, you are in space. The reasoning behind this is after 100 kilometers, the Earth's atmosphere becomes too thin for a conventional aeronautic vehicle like an airplane to stay in flight without reaching orbital velocity. So you have to switch to more specialized astronautic vehicles. But if you thought this was going to be simple, it's not. Even though the FAI's Kármán line designation is commonly recognized, there's actually no official international consensus over where space technically begins. Some astrophysicists say it should actually be 80 kilometers above the mean sea level because of the way the orbital momentum acts on satellite objects.
Right. Now, you guys, I'm sure you recall this between Branson and Elon, right? Which one really is hitting the atmosphere? Was it Branson and Elon, or Branson? Well, anyway, those two clowns that were
Branson and Bezos.
Bezos. That's right. God, I get those guys mixed up all the time. They're all clowns, regardless. But because Branson didn't get over that 100-kilometer mark, well, you didn't ever make it to space, and now you have to be on some sort of humanitarian type of mission, I guess, or in order to be considered an astronaut. So it's just so ridiculous how they keep moving the goalposts that it's ridiculous. And look at this, even this at nighttime, we're seeing this fluorescing all the way across the horizon. Of course, we never see this on the live feeds. This is only on the pre-processed or post-processed afterward feeds. None of these are ever live. In fact, you will never, ever, ever see, what they claim to be the live ISS feed as actually where the ISS is. It might be somewhere over your particular neighborhood, but if it's a clear day, it's going to show it as completely overcast because there are just certain things they simply cannot show, and they don't. So rather than get busted dead to rights with it, they would rather show cloud cover over the entire country, which they often do, than to, show a real live feed. And they can't because they're not up that high. What we're seeing up in the air is something that's much lower, probably between 50 and 75 miles up there would be my guess, right? And it's likely a U2 that's outfitted with some sort of ultra bright LED, or it could even be possibly a hologram that is being projected in much the same way as the artificial stars are, for correcting for atmospheric distortions. So, but
another
yeah.
thing that
NASA
you
and the
never
US
see
Air
on the
Force.
ISS live feeds, they never show you the horizon. So like on that nice, beautiful curved horizon with the afterglow, you never see that. They only ever have their cameras pointed straight down, right? And of course, like you said, it doesn't seem to match the weather of where they're over, right? Let alone the lightning bolts and the street lights. You never see any of that. It's just such a forgery. And I mean, we picked up on it pretty easily, but yeah, they seem to get away with it with the majority of the world.
Yeah, it's amazing, isn't it?
Well, yeah, there's still people claiming that they have a 24-hour live feed. Obviously, they don't have a long enough attention span to watch for 45 minutes because every 45 minutes it shuts down for 45 minutes.
Oh, well, they have a 24-hour live feed, but not a live feed.
They can't do it from the dark side of the earth, they claim.
Yeah.
They can't. It's like, really? I can watch a live football game from the dark side of the earth. I can, you can watch anything from the other side of the earth. Why can't the ISS connect? They have astronauts from all these different countries. When it's not over the United States, it's probably somewhere over China or something like that. They can't connect with them over there. I don't get it. I just don't understand.
Don't you know it's hard to be NASA?
It's hard to be NASA. Absolutely. That's crazy. All right, so let's continue watching this and see what else she says here.
Also define space as starting about 80 kilometers above the Earth's surface, and those who cross that line officially become astronauts. Okay, so the definition of space is up in the air, but what even is the atmosphere? Yes, it's the bubble of gases that shield and insulate the Earth from the aggressive radiation of the sun and the cold, dark depths of space, but like most complex things, it's got layers. The troposphere, with all our fun weather and necessary gases for breathing and surviving. The stratosphere, where commercial airlines fly when possible because there's usually less turbulence. The mesosphere, where most meteors burn up and the highest layer at which clouds can form. And then comes the thermosphere, which is where that tricky Kármán line lives. And this is where astronauts begin to experience weightlessness and is where the ISS orbits. That means that technically our most commonly defined line of where space begins is still in Earth's atmosphere.
Yeah, and you know what's weird about that is the thermosphere, and this is where astronauts begin experiencing weightlessness. What is that supposed to mean? It's like,
well, I mean, they're still in 95% gravity according to them. It's only due to the trajectory that they even experience any weightlessness.
Exactly, because they're theoretically falling the whole time. But in fact, if gravity is like what they say, and in this particular case, I will accept it because, in my opinion, gravity, or the phenomena that we're seeing that causes this downward acceleration, is in fact electrostatic, and that electrostatic law would apply, or I would say that the inverse square law would apply to the electrostatics of that situation, right? So, I mean, I can accept that, but as far as, what she's saying, it sounds like, well, you're getting far enough away from the Earth's gravitational pull that you're going to start getting, a little bit of weightlessness. And it's like, no, because supposedly, like you said, it's supposedly at 95% still up there, right? So the only reason that you are experiencing any weightlessness is because you are darting forward at 17,500 miles an hour, and you are also theoretically falling at the same speed. Now, I know
it's an never-ending parabolic arc. That's what they're doing. They're not weightless. The ionosphere, which causes the downward vector and the downward force, they claim they're not even halfway through it. It goes up to 600 miles off the Earth's surface.
Right.
So they are still well within the electric field of Earth. So gravity doesn't even come into play here. Gravity has nothing to do with it. They
Yeah.
are still within there. Like you said, for this to work, they would have to be going that fast and just always constantly falling.
That's right.
Never-ending parabolic arc.
That's absolutely right. And so then that begs the question, if that is true and the ISS is actually traveling 5 miles a second forward velocity and obviously would be falling at 5 miles a second, right? Wow, that is falling really, really, really fast, right? So the question is why does it stop there? If the gravitational pull, or the equation for it, is 9.8 meters per second squared, right? The acceleration downwards, then why is it that they don't have to keep increasing speed? Why is it hit a limit there? Is it some sort of a terminal velocity that there is enough atmosphere out at 235 miles or whatever it is, right, where the IS supposedly is, that it only drops at that speed? Because as we know from seeing the oh crap, I always forget the name of the guy that jumped from the parachute so high.
Baumgartner.
Baumgartner, yeah.
Baumgartner.
Yeah, Felix Baumgartner, right? Supposedly he hit over 700 miles an hour. He went super freaking sonic, right? And it's like, and then when he finally got far enough into Earth's atmosphere, and by the way, he almost completely passed out. And that is exactly, by the way, what NASA, a specialist from NASA who works with vestibular systems, says will happen if you are constantly falling all the time. The body cannot handle that. It disorients the body. And what happened to Baumgartner? He said he thought he was going to pass out, right? Get sick, whatever. And, I've done a couple skydiving jumps myself, and I can only imagine what it would be like to be in that falling feeling sustained. I mean, I am sure you would get sick because after a while you just can't deal with it. So that's another reason that I don't believe for 1 second that the astronauts are able to do this, because their vestibular systems would be completely hosed, completely. But getting back to that, so, if Baumgartner is dropping at supersonic speeds and then he finally got into enough atmosphere where he got down to and ultimately around that 120 mile an hour terminal velocity speed, then why is it that the vertical fall of the ISS seems to be stopping at 17,500 miles an hour? Now, if they went faster, if they went higher, does that mean they have to go faster? Something like that. And again, why does it seem to have this, balance point? I don't know. I don't understand how that works, but it just seems to me that if the formula is true of 9.8 meters per second squared, then what that's telling us is that it will keep on accelerating, which means that it should have to keep on accelerating on a forward velocity either. Also, forward vector as well. That makes sense?
Yeah, it should be exponential.
Yeah. So, I don't know, but of course we know it's all BS anyway, because every time we've looked at it, we take a look at the ISS and it's this thing that's going very, very slow. Comparatively, it's probably more like 500 miles an hour. And it's probably up at 50, 60,000 feet, So, and we've debunked this a million ways with Sunday, but what we're here to talk about today is, of course, the light propagation and why this is doing this. So let's continue this. I keep getting sidetracked, but let's finish out this video and then we'll move forward. Here we go.
And then finally, the corona with corresponding Lyman alpha radiation depending on the sun's position. So space telescopes that make measurements from within the confines of the exosphere will need to take a new Lyman alpha baseline level and the bunching of the geocorona into account when observing the night sky, hopefully letting us peer further and with greater accuracy. One last amazing thing about this piece of information is that this isn't even new research. These observations were made by Swan in the late 90s and were only just dug out of the archives for further analysis. What other startling discoveries could be lurking in a cupboard somewhere? Make sure to subscribe for all of your space updates.
Yeah, the bigger question I say is why are they waiting 30 years to analyze this data?
Exactly. What else could come out? Well, whatever they want, really.
That's absurd.
Well,
Absolutely absurd.
it's government. That's job security there, Bob.
Yeah, buddy.
30 years of job security right there.
Yep. So, okay. So 22 miles up, high altitude balloon. Gosh, I forgot. Was this the one no, this is the one we didn't watch yet, or was it? Wait a second. Yeah, we did. Oops. Okay. Yeah. So this one, what we're looking at again is a high altitude balloon observation of the sun. And again, even when it's still barely on the horizon, right? You can see that it's an extremely localized area that's lit up.
Yeah, just like the hot spots on the sea and in many high altitude balloon footage.
Mm-hmm.
How could you possibly have a hot spot?
Yeah, look at this. And here we have literally a terminator above the horizon. How is that possible?
Yeah. Yeah.
So, I just don't understand. Go ahead, Jack. I'm sorry.
I was just going to say that makes no sense.
Yeah, and yet we're seeing it, and this has been photographed multitudes of times. People have been in airliners, and you can literally see the brightness of day and the darkness of night on the same horizon, above the horizon, right? It's like, how is that possible? It just doesn't make any sense unless the sun is local. Because if it's 93 million miles away, whatever is on this side of the earth that is within that 180 degrees facing the sun, that entire horizon should be lit evenly all the way across. Now, there's no way around that, right? That's just a fact. They cannot get around that. So how do they explain stuff like this?
With a bunch of fancy words like she did.
Yeah, no kidding. So, I don't know if this...
they talk about instruments that they have in places that you can't even go to test yourself.
That's right. But
that's how they explain it.
But if we go to the flat Earth model, where it's all flat and the sun is localized, right, and it's much smaller, then what are we going to see? Well, we're going to see exactly what we do see. We're going to see a localized area that's lit up with a finite area that's lit, to each side. And as the sun goes up, further and further up, then that distance to the horizon, that throw or the distance to the horizon for the light is going to go further. Now, this is something that's really interesting, guys. Let me show you something that I think is really amazing, right? Let's look at a distance to the horizon calculator. Let me get one of these. Okay, so we have this thing. Now, if we take, I'm going to put this in feet. Let me bring over a little calculator just so you can see that I'm not cheating. But if I take this number, 180,360,00 divided by 5280, okay? You see that number, 3415.9, right? So that's how many miles up that would be. Okay, so if I wanted to go up in the sky and I wanted to cover, if I wanted to send a light up at the sky, right, high enough so that that light could theoretically be seen to the ends of the earth, right, then I would need to go up to theoretically the distance of the horizon, right? Because the light would throw to the distance of the horizon, right? So if I take this and I go, since this will only take it in feet, and we can see that 3415.9, which is really close to pi, is the distance in miles. So let's put that distance in feet in here. So 180,360,00, which is 3,415 feet, and we calculate the distance. Look what we come up with, 6224. Now, if we take that and we double it, then we're going to get 12,000 450 miles, right? And that is exactly half the circumference of the Earth. Isn't that interesting? Right?
Mm-hmm.
Wow.
Mm-hmm. There's lots of things like that as well that tally like that. You see, I don't think they can lie about certain things, like the radius line or the equator line, and there's lots of ways like this that I've seen that correlate with the numbers that we're saying.
Mm-hmm. Absolutely. But isn't that interesting? So we basically are having this, and that 34159 point. Now think about this for a second. What have the flat earthers been saying the elevation of the sun and the moon are, right? About how many miles? Somewhere between 3,400 and 3,800. I would say that 3,415.9 is right there, right in that zone, right? So isn't it interesting that if we are saying that the sun and the moon and or moon is in between 3,000 and 4,000 miles up, and I'd say closer to the 3,500 mile range, isn't it interesting that that is exactly the altitude that is required to throw light to half the Earth at a time? I mean, what are the odds, right? What are the odds?
What are the odds? It's almost as if it was designed.
Yeah. I mean, people think about this. My God, this is absolutely mind-blowing, right? But nobody ever really thinks this through. And it's like, so the flat Earth, works out perfectly. And you guys have all seen me do the Red's Rhetoric demonstration, or TJ does his demonstration where he triangulates the distance to the moon, right, with his friend Turkey Cat. You guys have seen that, right? This person Jade is in Florida, or maybe he's in Florida, and one of them's in Florida, one is in California. So Red, comes up there and he says, okay, so this is the difference between me and Jade, and my angle is 90 degrees and hers is 60 point whatever it is, and then you have to figure in that parallax value, right? And then we crunch the numbers and it comes out, look at that, it's 234,000 miles to the moon from his front door. Great. But then what TJ does is he says, well, yeah, but what if we don't put that parallax figure in there and we assume that the Earth is flat? Then what does it come out to be? Well, it triangulates to be 3,409 miles is exactly what it comes to when you don't put the parallax value. So you put that value in there, that's where the moon and the sun triangulate at, is in those two points. And actually, we just recently saw Jay Tolan Media One, right? And he said he did this major experiment where he was trying to triangulate on where the sun actually is. And you know what he came up with for the distance to the sun? 3,959 miles, the radius of the Earth, right? 3,959 miles. Oh my God. Right?
Unbelievable, isn't it? But what they also didn't say was that, if they're triangulating on the moon at 230 whatever it was thousand miles, then that's exactly what the distance of the sun would be away, without them presuming that it's 800,000 miles or whatever it is these days, 400 times that.
Exactly. And of course, you will never see a baller apply that same trigonometry to the sun. Because if they did, then they're probably going to get exactly what Jay Tolan got, which is the 3,900 miles. And that's using the exact same formula. And, I haven't run this in a while, and maybe I should, just because few people have seen this, but this is really, really worth seeing. Let me just run this.
Yeah,
Sorry
Jay
for being
Tolan's doing some fantastic stuff at the moment. It really is. I mean, he's just kicking it out of the park so many times.
Jay Tolan?
Yeah.
He is. And what's funny is that guy, I Can Science That, he thinks that Jay Tolan is trolling the flat earthers. He goes, you guys are so dumb, you don't even realize he's trolling you. I'm like, what? How is he trolling it? He goes, because everything he does shows the world as being spherical. And I'm like, dude, you picked the wrong day to stop smoking crack, man.
It's so easy to say, isn't it?
Oh my God. They They just pull this crap right out of their butt, completely.
Thanks for proving the Earth's round. It's like, are you retarded or something?
Yeah, exactly.
Yeah, just looking for a response, trying to get one more response out of you.
Yeah, it's on their script. It's well used tactics of the retarded.
Yep, absolutely. All right, so this, I apologize for everybody that's seen this, but this, like I said, is absolutely classic. Everybody knows who Red's Rhetoric is. Math is reality. He's the guy that unquestionably, thinks he knows it all. And boy, he really stuck his foot in on this one big time. And, like I said, when you take this number that he comes up with, 3409, I came up with 3415. So we're talking about a 6 mile difference, whatever. It's still going to give a distance to the horizon of, half or a quarter, I should say, the circumference of the Earth. And of course, you have it in 2 directions, and you're going to cover half the circumference of the Earth, which is amazing. It's an absolute dead match. So let's listen to Red's Rhetoric, a little bit of language in this, guys. But, this is so classic, the way TJ just makes him stick his foot in his mouth. It's awesome, right? So let's listen to this really quick.
Depends on what reality is. So that's the only thing that can prove who is right and who's wrong. But you'll see how actually they're both correct. So let's get started with this. And I just went ahead and fast forward. This is around 7:45 minutes. And we're going to take a look at what he's saying.
Your line of sight with the object. And using parallax to find out how far something is nothing more than trigonometry.
So we're going to use trigonometry. I've got a formula set up for that right here. I'm just going to punch in the numbers and it's going to give us the information. So basically, between 2 points and up to the moon, we're going to measure how far the moon is. So what did Jeranism say? Jeranism said that the moon is, here it is right here,
away, which, by the way, is the next thing we're going to debunk. You said, and I quote, the moon is 100% only 3,000 miles away. Now, one would be perfectly justified in asking where the hell you're getting this information from. Another would be, have you ever tried to figure out the moon's distance for yourself?
Okay, you ready? Because we're going to figure out the moon's distance for ourselves using trigonometry, which he says works.
Guessing the answer to that last question is no, and the answer to the first question is, well, we're actually going to leave that one alone. Now, the way we can find the moon's distance from the Earth is by using parallax. Parallax is why nearby objects appear to move more than farther ones when moving perpendicular to your line of sight with the object. And using parallax to find out how far something is nothing more than trigonometry. If you wish to find out how far away something is, all you have to do is follow this formula, and we will use this formula to find out how far away the moon is from the Earth. Now, the way we're going to do this is that YouTube user Jade, aka TurkeyCat, who's located in California, will be measuring the angle at which she sees the moon relative to the horizon. She will do this edge-on with my location in Florida, and I will do the same while being edge-on with her location in California. However, the first thing we need to do is find the distance between us. Lucky for us, the distance between us is known by, you guessed it, using the fucking ruler tool on Google Earth. With that, we now have the value of D, which is 2,351.81 miles.
Okay, so we need to take this 2,351.81, 2,351.81. Okay, 2,351.81. Okay, so just round it up to 82.
Now what we need is the angle at which we both see the moon. And here are the results. Jade makes her measurements and finds the moon to be 55.4 degrees from the horizon.
Okay. She sees the moon at 55.4. I'm going to put that right here, and I'm going to show you why in a little bit.
These measurements were done when I found the moon to be directly overhead at 90 degrees, edge on with Jade's location in California.
Okay, so his is 90 degrees. So we've got degree number 1, 90, and we've got her degree 55.4. So let's keep going.
With these values now accounted for, there is one more thing we need to take into consideration, the curvature of the Earth. Yes, that same curve that made the ship disappear from our line.
By the way, I did a video on this ship. This is complete horseshit. Red's Rhetoric. I can't believe you got fooled by this dumb-ass video. This,
sight,
oh my gosh, this video fakes so many people. Just watch my video on the...
Yeah, go ahead.
So, is Red claiming that the moon was 90 degrees over his head?
At that particular time, yes.
and he's in Florida. I thought the moon stayed within the tropics.
Well,
how could it ever be 90 degrees over his head?
Well, that's where he would be measuring it from. But yeah, it's probably a really good question. But because in order for it to be directly above his head, it would have to be in between the tropics of Cancer and Capricorn. And I don't know what part of Florida he's in or she was in, but maybe it's far enough south. How far south does Florida go? I don't even know. What's the latitude of Miami?
I'm going to look.
Let's see. That's a good
think
question, though,
it's in the
Zach.
30s. I think it's in the 30s, 25, 30s.
25 degrees. So there you have it, 25.7. So it's a few degrees off. Okay? But whatever.
Yeah, it's got to be. Yeah, okay. Just making that, because that threw me off. I was like, wait a minute, the moon doesn't go that far north.
Yeah.
How could he be at 90 degrees? That doesn't make any sense.
Yeah, and I don't remember which one's in which, but it doesn't matter. So let's continue on with this. Here we go.
Ancient ship and just whatever. This doesn't prove nothing.
Seen previously. You see, as you get further away from a point on the Earth, the more deviation you will get in your visual angles. For example, if...
Now, I just want to make a point right here. If we're on the curved Earth, which, fine, let's say we're on a curved Earth, why is it when we fly, whatever, we don't ever see buildings leaning away from each other like this? And they have to, because certain parts of the Earth are curved away from others. So at some point when we're on a plane or we're on, some type of ISS, space station, when we're on something, at some point we've got to be able to see buildings that are curved away from each other.
Okay, and in response to that, TJ, and I made this same correction last time, is yes, theoretically, according to the globe model, the buildings would be tilting back 1 degree for each 69 miles that they are away from each other. But obviously, there's no way that we could ever see that. Even if we were standing right next to it, and it was 1 or 2 degrees out of square, it's highly unlikely that you would ever even notice it, let alone from hundreds of miles away, right? So I'm not really sure why TJ brought that up, but let's just ignore that for now. Everything else is hunky-dory, and we're proceeding along normally with the math, and we're going to watch Red's rhetoric completely screw himself right here. Here we go.
But we never, ever, ever see that.
Jade were to look straight up in California, and I were to do the same in Florida, we would not be looking in the same direction. There is a deviation there caused by the curvature of the Earth. How do we correct for this? Simple. A complete circle is 360 degrees. So if we divide the circumference of the Earth by 360, we will get 69.169 miles per degree of change. Now, if we take the distance between our two observers and divide it by that number, the miles per degree of change, we find that our visual degree difference is 34 degrees. So what this means is that we will need to add 34 degrees to Jade's measurements in order to offset the difference.
Okay, so we need to offset the difference for the curvature of the Earth. So we're going to look at 2 ways. One is the Earth is flat. Doesn't mean a pancake. You look with your eyes, you see that there are dimensions up and down to the Earth. We need to make note here for curvature of the Earth, and we're going to do that. But what if the Earth is flat? If it's flat, then we don't need to do this. So we're going to see what the two differences. Remember, Jeranism said it's only about 3,000 miles away. And this guy says it's horseshit. If you use trigonometry, you'll see that is wrong. So let's find out.
Which, when we do the simple math, gives us a new value for Jade's observations.
So now Jade's observation, which she saw, was 55.4, right? 55.4. Like, nope, sorry, the Earth is curved. We got to add 89.4 degrees. So we have to make it to where I'm at 90 degrees and you're at 90 degrees, shy of 0.6. Let's keep going.
Value is 89.4 degrees. This means we can now find our parallax. Now the inner angles of any triangle will always equal 180 degrees. So
okay, so he brings us up that the angles in a triangle will add up to 180 degrees. So here we have angle 1. My formula up here up top. Let me pull this down a little bit. So you see that there's no formula in this box. Next box, no formula. And then this box, what I'm doing is we're taking 180 minus C26, which is this first angle, and then C27, which is the next angle, and it's going to give us the third degree, which is not masonry, but it's the third degree of the angle. So it's going to do this subtraction for us. Now, what also is going to happen down here, we have more of the formula. So C25. So it's going to take the distance, which is C25 right here, and then it's going to take the tangent and the parallax, and it's going to give us the miles. So we're going to see that here in a little bit.
We simply minus the total degrees we observed from 180 degrees, which gives us a parallax value of 0.
Okay, 0.6. Let's get that over here. 0.6 is what he says, but it's actually 89.4. So what I'm going to do is put in 89.4 here. So these are the 2 degrees we're going to play with.
0.6 degrees. And finally, we now have everything we need for our equation to solve for x. So x will represent the distance from the moon to my location in Florida. So we simply plug in the values where they belong, crunch them out, and what do you fucking know? We found that the moon is 224,573.102 miles from my front door.
Okay, so it's 224,573 miles. Okay, so let's see what we get. Let's plug in 89.4 because we had to account for Earth's curvature, and forgot that there we go. So we have to account for Earth's curvature, which gives us a parallax of 0.6, which makes this 224,573.1. Is that right? 224,573? 224,573.1. Okay, so this formula works. But what if the Earth is flat and we put in 55.4 for this degree? We go back to her original degree that she had because we say, all right, what if the Earth is flat? That's what Jeranism says. Oh, wait a second. Now the moon is 3,409.143 miles away. So let me just ask you a question. Does the moon look like it is 3,409 miles away? Or do you think it looks like it's 224,500 miles away?
Well, honestly, I think it looks a lot closer than both. But again, you know, not to beat a dead horse, but even if we do the 3409, 3409 was it 0.1 or whatever times 5280 gives us 18,048. And then we take our distance to the horizon, plug this in there, bada bing, calculate it. Obviously, I screwed something up. Distance to the horizon, 180. What did I do wrong here? Did I go backwards?
You must have.
180, 36000. That works, right? Okay, 6224. I must have done something wrong in the math. Anyway, regardless, it's only a difference of 6 miles, right? Between what Red's calculated and my 3415, right? And so the flat earthers are saying that the sun and the moon are essentially somewhere between 3,400 and 3,900 miles, you know, respectively, right? And it's just so interesting that that works out so perfectly for the distance to the horizon, the throw of light, all that stuff, right? It works out absolutely beautifully. And the other thing that I found was really amazing by this, just the number play itself, is 180, of course, is half of a circle, 360 is a full circle, 00, you do that, and 6224.5 miles is precisely 1/4 the circumference of the Earth on the nuts, right? So you know, you cannot ignore stuff like that, guys. This to me is not, it's no coincidence. This is about as real as it gets, and it is some massively huge proof. Thank you, Red's Rhetoric, for making math reality. So all we have to do is take out the one variable that we don't ever observe, ever, and that's the R value, right? Because the ballers, try as they might, have never been able to show us an R value. And lo and behold, we have numbers that work perfectly. They fit perfectly with reality. What we see the sun lighting up a local area on Earth instead of the entire half of a supposed sphere at one time. I mean, it's all there, man. It's all right there. You just cannot get away from it. It works perfectly.
And how does he explain if you did this for the sun, it would come up with the same figures, even if he put his curvature of the Earth in there?
They don't address that.
Okay, right.
They do not address
Job
it. And of course, we know
Next
that
question.
the sun and the moon both are apparent positions. Why? Because we're actually looking at them through a huge magnifying glass. Now, whether that magnifying glass is the firmament or it is just a property of the atmosphere, it's real, right? There's no doubt atmospheric lensing is real. Even the experts will acknowledge it 100%. Rob Skiba did a video with that weatherman, that said, what you see here is a mirage. That guy who, after he made that broadcast, he got 1 million people writing in saying, oh, no. That was no mirage, whatever. What's going on here? So he went to an atmospheric expert and then did a follow-up broadcast. And the atmospheric expert said, well, yeah, what's happening is the atmosphere is magnifying, right? It's absolutely magnifying what we're seeing here. Well, we know that. That was obvious. Rob Skiba was able to prove that hands down. So there you have it, right? And so they simply don't address that. Now, Dr. Zack, as we covered his video, was it last week? I don't remember when it was. It was either Sunday or last Wednesday, where he was able to take mathematically and create a mathematical formula that made a flat table into a sphere. And he was able to do that basically by putting up one of those little half magnifying glasses, to actually project the light through. Again, this would be emulating like if you're at the bottom of a swimming pool and you look up to a light that's outside of the swimming pool, its position is offset, same as it would be if you're looking into the water. You have an offset value there, right? Because
the fish is never where you see it.
Never.
I was going to say
where you see it.
People have known this since
forever.
Since we were put on there.
As somebody who does the
spear fishing. Yeah.
They know where the fish is. It's
you always got to aim ahead of it, basically. Yep. So that's essentially how we're seeing the sun and the moon, right? Now, of course, they will use this to their advantage. Sometimes they'll say, well, you remember that refraction? That's what allows us to have Selenelian eclipses, right? And of course, the Selenelian eclipse is what? It's when you have the sun and the moon above the Earth's horizon at the same time. But then in that particular case, it just so happens that it draws down the apparent position of the sun and the moon about 1/2 degree. And bada bing, that's what gives us our Selenelian eclipse. That's their excuse for that. This is like, oh my God.
And they don't talk about the shadow coming from the top or exactly where it's not meant to come from.
That's right. They do not acknowledge that. And in fact, they'll say, well, depending on where you are in the Earth, it'll come in different positions. It's like, yeah, but it'll never come in from the top. Especially because these eclipses are only visible from certain places on the Earth. And whether it's in the northern or southern hemisphere, it's a very, very finite strip of land, right, that you're able to see it over. So, but they'll just pull this right out of their butt and say, well, yeah, no, if you're in different places around the Earth, like if an eclipse happens in the northern hemisphere, they'll say, yeah, but if you're in the southern hemisphere, you're seeing it from the opposite direction. It's like, no, you're not seeing it at all because you're not in the eclipse zone. But they will still tell you that, right? It's just unbelievable.
I misspoke earlier. I guess the moon does not stay within the tropics. It travels about 5-point-something degrees more, up to 28 degrees.
Oh, okay. Well, thank you for. That's right.
That.
Somebody told me that before, and I totally spaced that. But you're absolutely right, Zach. So whoever corrected us, thank you. See, even we screw up every once in a while. But regardless, it was an honest mistake, and it was certainly in our favor. So there we have it, and in Red's favor. So no matter where he was in Florida. His angle to the moon could be legitimate at 90 degrees. So there you have it. So let's see.
I had to go check and verify that. That's why I was quiet there for a minute.
Oh, you
I
did
was
that?
looking it
Okay.
up.
I thought somebody else did
Yeah.
that. Well, then kudos to you, Zach, for correcting yourself on that. But yeah, I was thinking that too. But you're right. It's only the sun that stays in between the tropics. Now the moon goes in between the tropics every month, though, right?
Yeah, that's what I thought. Sun does it yearly, and the moon does it monthly.
Yeah, the
month.
moon makes its traverse north and south once a month, where
Yeah.
it takes the sun a whole year to go.
Right. And
From
apparently it
tropic
goes to
back to
28 degrees plus or minus instead of the 23.5, right?
Mm-hmm. Yeah.
Okay, cool.
Which is weird. I'm going to have to think about that now.
Yeah, I know. Well, they give us such a convoluted. Well, that's actually reality, but you have to be very careful not to, get trapped into using the math from their particular model, right?
I know it.
And that's why I did that show why do we use their terms and their math and all that stuff. So anyway, it's pretty crazy. So, all right. So the reason again that I want to talk about, light and stuff that we see is now I did this with the moon. You guys probably saw my presentation in Dallas where I was talking about how bright the moon would have to be to actually get a light down to us at a measly 0.1 lux, right? Which 0.1 lux or 1 lux, somewhere in that zone, is bright enough to read a book by, but not much more than that. But we back engineered it, and it turned out to be 4.7 quadrillion lux, I believe.
Yeah. Yeah.
Which is insane, right? It's absolutely ridiculous. But I want you guys to think about something, right? So if the sun, our sun, and I'll actually pull up some of these. Let me pull this up really quick. Let's go back to the sun. All right. Yeah, I've got that. Let's see. Hang on just a second. Let me get my shit together here. Yeah, this was actually, I was looking at the ISS and the angular stuff. I'm looking for one chart. That's the moon. God, is it not on here? Okay, well,
the moon and the sun are so different. I mean, that they're about the same size. The moon actually changes size, I think 13% over its month from the southern hemisphere to the northern, and it's different. The moon is bigger when it's in the northern hemisphere, and the sun is bigger when it's in the southern hemisphere.
Interesting.
So, yeah, I don't know.
Yeah, but
I quit trying to figure it out, but it still draws me back in every now and then, and I go mad for a little bit.
It probably has to do more with the wavelengths that they're putting off, because, the moon is obviously weird. It's a plasma type of light, which is something that we have never really been educated on, because plasma light is actually a cooling light. And this is the reason why moonlight is actually cooling. And even all the ballers know that. Slice Barkane did it, measured it as cooler. Ken Wheeler measured it as cooler in the full moonlight, right? So even the ballers, we're not getting any argument from them. We're also not getting any explanation for it either, because if it supposedly is reflecting the sun's spectrum, then how in the hell could it be putting off a wavelength like that? Sorry.
Well, and their mainstream explanation says that it is fractionally warmer. The moonlight is fractionally warmer, although they have no way of showing that. But a 5-year-old can go out and show you the exact opposite.
Yeah, exactly. It's interesting. So anyway, while I was doing my presentation in Dallas, I was trying to give people a reference to both the size and the brightness of the sun, right? And so I came up with this chart. And so basically what they tell us is that the sun at 93 million miles away, let's just put it that way, has a diameter of 865,000 miles. Okay. Now that is friggin' huge, right? 865,000 miles is pretty incomprehensible, because we really don't have anything that any of us can draw on to, even comprehend something that big. But
But it could be 400 times bigger than that, according to them as well.
Yeah, and it'd have to be a lot further away, and that has to do with I forgot what Jeran called it, but in scaling invariance, I believe is what it's called. Yeah. So we're gonna go with NASA's figures, and of course we had to laugh because during the eclipse 4 years ago, NASA was starting to backpedal and say, "Oh, you know what? The sun looks like it's a lot bigger than we thought it was." And then they decided that probably wasn't a good idea because if that fell, then their entire model fell. So they just took all that stuff down, right? I don't know if you guys remember that presentation or not. And I don't remember if I did that on Sunday or last week, but regardless. So if it's 93 million miles away and it's 865,000 miles across, then by the time that it gets to us, a mere 8 light minutes later, right? The distance that it travels at the speed of light in 8 minutes, which is 186,282 miles. So let's just see how many miles that is, just for grins. So if I go 186,282 times 60 times 8.3 technically. So let's just give them the benefit of the doubt. 92,768 miles, right? Okay. So it travels here and it reduces from that 865,000 mile diameter to 0.52 degrees in angular size, right? About the size of a frisbee up in the sky or a small ball or something like that. Not very big, little small. Well, you know what the sun looks like. The sun and the moon are both about a half a degree in size, right?
So the size of your thumb.
Yeah. So when I was talking about this, that not only does the sun have this problem with its angular size that decreases inversely to its distance, right? But it also decreases to the square of the distance in brightness, right? So in other words, every time you double the distance, it goes down to half what it was in angular size, but it actually goes down 4 times in brightness level, right? So if you take the sun, and NASA tells us that our sun, good old Sol up there, is an average star, right? In other words, it's not the biggest, it's not the smallest, it's considered an average star. And in 8 light minutes, it's 0.52 degrees. So if we double that distance, then that's at 16 light minutes at 0.26 degrees angular size, right? Now it's getting pretty small. Double it again, 372 million miles, 32 light minutes, 0.13 degrees angular size. Double it again to 1 light hour, it's 0.065 degrees angular size. Okay, now I made a note about this. The distance to Saturn is 893 million miles, and we'll get back to that maybe later or not, but whatever. So we're going to double that distance again to 2 light hours, and that takes us to 1,488 million miles, and now it's at 0.0325 degrees angular size. Now, just a small amount of angular size below that is the limit of our visual acuity, which is 0.02 degrees or 1 arc minute is the limit of our angular resolution or our visual acuity. In other words, we can't see anything smaller than that. And here at a mere 2 light hours from our sun, which is an average size star, guys, we're already almost there to the point where we can't see it anymore. That's amazing. Okay. So let's keep going. So let's go to 4 light hours. 2,976 million miles gives us a resolution of 0.01625 degrees angular. Well, guess what? Right there, it has gone out of our size resolution limit, our angular size resolution limit. So the only thing that we're going to be able to see is the fantastic amount of brightness that's coming off the sun. But again, remember, every time we double our distance, our sun's brightness goes down 4 times from what it was at the previous mark, right? This is not a guess. This is not a conspiracy theory. This is a law of physics, guys. Okay? So let's keep going. 5.9 billion miles is 8 light hours, or 1/3 of a light day, right? And it's down to 0.008, which is way smaller than what we can see. And finally, if we go to 2/3 of a light day, 11,904, 16 light hours, it's just completely gone, right? So I asked at that time, gee, I wonder what that looks like, right? So I just Googled it like anybody would, right? So what did I come up with? Let's see what I came up with. How does the sun appear on other planets? This is a good one. Now, this is really cool, guys, because what they're going to show us is this little chart here, and this chart's pretty cool, all right? And if we're on Mercury, which of course is, quite a bit closer, it's going to look about like this. So it's going to be, well, actually, I have a little chart for that. Let me go back to that really quick. Hang on just a sec. Bink. Let's go to this. All right. So Mercury is 0.387 distance from the sun. So the sun from us is 1 AU. So Mercury is about 1/3 that, a little more than 1/3 that, okay? With a relative solar intensity of 6.68 times. In other words, Mercury, the sun from Mercury is 6.68 times brighter than it is here on Earth, okay? Then from Venus, its size is 0.723, okay? And that gives a relative solar intensity of 1.913, so almost twice as bright on Venus than it is on Earth, okay? And Earth, of course, is the benchmark. We don't have to trust NASA for this. We can measure it ourselves. So there we have it, R1. And then as you go out to Mars and Jupiter and Saturn, and what's funny is when you get out to Saturn, we're down to 1%, right? 1% of the sunlight. Wow, that's pretty bad. But let's keep looking at this. So let me minimize this. So let's look at this. So here's Earth, and this is our 0.52 angular resolution. Here's Mars, Jupiter, Saturn, right? And of course, these are getting down to the size of stars, right? Well, Neptune, it's no bigger than any other star, right? And they even say this in this article somewhere. They say that by the time it gets out to Neptune, it's no bigger than any other star. And guys, we're not even a light day away from the sun. So how in the hell can our next closest star, which is Proxima Centauri, right, be 4.3 light years away, and we can possibly see that? How is that even possible? It's bullshit, is what it is.
Times further away, yeah. And they say the North Star is less than 20% the size of our sun.
No. They
so
say
how
it's
do we see the North Star?
No, they say it's 400 times larger. But they also say that, well, one assessment is that it's 450 light years away, and now they've reduced that to, I believe, 320 light years away. Let me double check that just to make sure. Polaris. Well, let's try star.
We'd never see it.
Yeah, I ain't buying it for 1 second.
No matter what they revise the figure to, unless they revise it 400 times closer.
Yeah, so here they say the revised parallax gives a distance to Polaris of about 433 light years. And then they did something that brought it to like 35% closer, 320,000 miles. And the funny thing about this is Dr. Danny Faulkner, who completely jumped all over me for my analysis, right, at FEIC. Once I brought this up to him the next year, I said, okay, Danny, well, I was using the 450 or the original 450 light year figure that Wikipedia did. You did your math and you confirmed it. And everything was correct. And now they're telling us it's the 320 light years, a full third difference, right? Just a mere 130 light years difference. You know what he said? Oh, it doesn't matter. It doesn't matter.
Science doesn't matter.
Science, brah. It don't matter. Yeah. What a lying clown that guy is. He's unbelievable. So yeah, it does matter. It matters hugely. And, Polaris is supposedly, and it's supposedly something like 400 and, solar masses. Gosh, where is that? Visibility. Anyway, all I'm saying is if you just keep in mind that our sun is an average size star and basically it's too small to see at 1 light day away, how can we see anything at a light year or 4 light years or 100 light years or 1,000 light years or a billion light years? I mean, that's so ridiculous. And I got news for you guys. Telescopes do not have that high of a magnification. They just don't. And how can you find that out? If you have a nice telescope, like, I had the Meade LX200 10-inch, beautiful scope, and with the highest magnification eyepiece on there, I could take it up to Lookout Mountain and I could see the other side of Denver about with the same magnification that I could see with a really good pair of binoculars, right? They do not have that much magnification, guys. So to think that these telescopes are just going to miraculously bring these objects that are hundreds and thousands of light years into your visual acuity, again, you have picked the wrong day to stop smoking crack. It doesn't work that way, right?
And
Sorry.
how far away did they say that they took a photo of a black hole? That was something like
1.3 billion light years away. and I know, it's like, give me a break, man. And get this, it was a black hole, right, of complete darkness. So again,
yeah, exactly.
and so how do they take a picture? How do they know it's that? Well, because they can see the light that they know those lights are around it, bending towards it, and that's how they know it's there. I mean, my God, people are dumb to believe this stuff.
Math is reality.
Yeah, math is reality. Math is just scary. It can be, it can be so misleading and so deceiving. It's just
maths is a language. It can lie to you. It can tell you the truth. It depends how you use it. It's just a language.
Yeah, you can write an equation that shows how a blade of grass is holding up an elephant. It doesn't mean it happens in reality. It's just math. It's just written down on paper, just like a lie would be.
Yep.
No difference.
Yeah.
Exactly. So, and here we have, just to back it up, another source. So we've already determined by the time you get to Neptune, it's basically just another star, right? Nothing bigger. So all these other things, which are supposedly, the closest one is 4 light years away, and most of them are 400, 500,000 light years away, whatever. It's like, give me a break. They're showing this, and they're not really being honest about this either, but, and I like the way they do this. They show artist conceptions. What do they label as? Mercury, which is 58 million kilometers from the sun. So it's pretty big there. The sun as seen from one of the moons of Uranus. I think that's a little generous, but whatever. You get the idea, right? Yeah, it's just ridiculous. Now these, like I said, this is much more accurate. And again, not only are these so small, but then you have to ask yourself, so Saturn, we look up at Saturn, it's pretty freaking bright, and so are its moons, right? When we look at it, and yet it's only 1% of the brightness that it is here. So how in the hell is the sun lighting up Saturn so that we can then see it a billion miles, reflecting light a billion miles away, all the way back here on Earth, and see it so brightly with our naked eye? Again, this is horseshit. You can't do this.
It's just not.
So
they're all local. They're all clearly local.
They are all.
Well, yeah, the laws of physics that they wrote go against what they're telling us.
Yes, exactly. So, and like I said, light is the highest loss of all, especially traveling through free space. So, to think that even if somehow by some miracle you could transmit an EM wave, a microwave signal from Voyager back to Earth at 3 billion miles away, which is nothing, right? Which is nothing, in the cosmic scheme of things. You have light, which is not being put through any electromagnetic friendly medium like iron or not iron, not necessarily iron, but like a fiber optic type of cable, right? Because that's what we use here on Earth. And I'm sure there's probably other stuff that would be good at that, some sort of crystal. But we just don't have that. So, the lossiest thing out of all the EM radiations is the one thing that they want us to believe, that we can see at the most incredible, insane distances. Doesn't work, guys. And you are completely on a different planet if you think that it does. I mean, I don't even know what to say to you. It just, and if you're an engineer and you're supposed to be thinking about this critically, I really don't know what to say to you. But a lot of people are figuring it out because their common sense is taking hold. And they're saying, wait a minute, that crazy freaking Bob on Globebusters might be onto something here,
Well, yeah, they've made it so, they were never taught this in school, ever. Anything about any of the stuff that you're saying. So when you're using these terms, which are somewhat, they're scientific terms, that's almost like learning a totally new language. The first time you hear it, your eyes just kind of glaze over and you're like, he's a flat earther. He's just crazy. But then, when they start looking into it and start understanding what these words mean and the phrases mean, then it really starts making sense to them. So I understand it. I get it. At first, when you see this stuff, it's like looking at Greek.
Yeah.
If you're not Greek and don't know how to read it, then you're kind of lost. You're just like, okay, well, whatever.
But also to even admit one single one of these facts is to shatter your entire paradigm of what you've been taught since you were born. So there is cognitive dissonance in there as well. They may be able to understand this stuff. They may hear what you're saying. They may even understand it, but somehow in the brain, they discount it, because if they were to believe it, that would be it. Everything else is it's off the table.
Oh, wow. Wow. Somebody said that Austin got arrested at Mount Rushmore. Oh,
yeah,
crap.
I just saw that in chat.
Oh, Jesus. Oh, man. I wonder what happened. Well, I'm sure I'll find out. That's crazy.
It was waiting to happen, though, wasn't it, really?
Well, yeah, I'm honestly surprised that it didn't happen. I just wonder what the circumstances are. I'm sure it wasn't the same as what happened in Globebusters. Look at
Florida.
What's the channel now.
Not because of Austin's performance or his attitude or anything, but it was bound to happen. He's making too many ripples.
Yeah, no kidding. I mean, the day he... Oh, wait a second. Mount Rushmore?
So it's one or the other. Refusing to identify yourself is the problem. So you have to identify yourself to a law enforcement officer.
There you go.
Austin's going to own this guy.
So
I'm not sure what the laws are in
So here's the deal.
the Dakotas, though.
If we're amicable
Some
on
states
this,
are stopping ID
He
states.
told me
I could just walk to my car earlier.
No.
There.
I
Yes,
said,
you did.
I asked where
You
your
said
ID
where you parked.
was.
I know you were just being escorted out by the cops. Fine, you're escorting us out. Let's go.
Right.
Let us go.
Yeah.
You're escorting us
Honestly,
out.
sir, at this point,
That's what you
you
said.
refusing to tell us your name and your date of birth.
What? I'm sorry? Did you say something?
No.
Zach?
No one said anything.
No.
Okay, I'm
But
just...
if you don't give these guys your name, then you will be arrested and taken away for 24 hours. Same in the UK. They need your name. They need your date of birth in order to tie you to your corporate name in order to be able to do anything to you. So if you hold your ground and don't give them your name, then they will arrest you, but they will have to release you, well, here in the UK, within 24 hours or charge you. And of course, I doubt he's done anything chargeable. So, yeah, refusing to give you a name.
I was saying, there are some states in the United States that are stop and ID states where, you have an interaction with the police. I think there's 11 of them. Don't quote me on that. But I know there are some. I definitely don't visit those states. But,
well, they need your name. They need your address because they need to tie you back to something on their database. If you don't give them your name, then the only thing they have to rely on is you breaking common law, i.e. you've hurt someone, you've caused loss or harm or damage or whatever. Generally you haven't, which I'm sure Austin hasn't. So yeah, I mean, I'm resigned to the fact that if I get pulled over or I get stopped by the police, then I'm literally spending 24 hours in jail, and then I'm going to sue their asses.
Yeah, no doubt. Well, I'll have to go back and watch this because obviously this just happened. It's happening as we speak. So yeah, that's crazy. Well, Austin's smart enough not to talk to these idiots, I'm sure. Wow. Talk about a stacked deck, guys. This is what we deal with, you know?
Well, if you want an easy life, you tell them your name, your date of birth, your address, etc., and you hope to hell that they don't come up with some sort of policy or rule or statute or some other crap that they can charge you with. If you don't want to play their game, then yeah, unfortunately, they will kidnap you, and then you need to sue them.
Yeah, that's crazy. So there's Chris. There's Austin. Oh, nice outfit, Austin.
He's a white coat.
Jesus, unbelievable.
Fantastic.
Absolutely unbelievable. Well, there it is, folks. This is the kind of crap we're up against. So, well, you know, Austin will be back with us on Globebusters on Sunday, so I guess we will just figure that out. But
well, wish him luck. I hope he doesn't give them their name, and yeah, I'd like to see them press charges against him for doing nothing.
Yeah. Well, I guess we'll find out. He's certainly being cooperative, and Chris has got it all on video, so there we have it. Wow. God, that is just effed up. Ay, caramba. Okay. Well, anyway. Jesus, that really just bums me out. I mean, after that incident in Florida.
Lab coat.
Yeah, I know. That's the way it is. So, all right.
Well, luckily you're not in the state that Australia is in at the moment, because, yeah, boy, it's getting hot over there.
Yeah, it sure is. That's crazy. Of course, that's something we'll have to talk about on Sunday. But I guess before we close out today, I want to cover a couple other things that are in the news, and then I'm going to call Chris and see what's going on and see if we can help Austin get him bailed out, or if it's a 24-hour deal or what it is. I don't know. Whatever. We'll see what we can do to help him out. So anyway, we have this little item in the news. And it says, and it's from Gizmodo, it says the ISS backflipped out of control after Russian module misfired. New details revealed. A NASA flight director has provided new details about last week's scary incident in orbit in which a freshly docked Russian module inadvertently fired its thrusters, causing the International Space Station to roll backwards. Like, bullshit. I mean, I'm calling bullshit right now. There's no way. That whole thing rolled over backwards at 17,500 miles an hour. Oh, my God.
I think they're setting us up for the disintegration of the soon-to-be
the astronauts on board.
Yeah.
Oh, sorry, John. The astronauts on board said they didn't even notice it.
Oh, my God.
They saw a bunch of stuff flying off. I think it was fuelant or something like that. Yeah, one of them even tweeted about it while it was happening. That's what you see all the time, right? You're up in this place. Think of yourself at the bottom of the ocean in a submarine, and you notice something's going wrong. First thing you're going to do is tweet about it? Really? Life or death situation? Well, let's tweet this.
Yeah.
I mean, give me a break.
Yeah, no kidding. That's absolutely unbelievable. Talk about just setting the drama. I mean, this article is just horseshit. They said that it literally did a 1.5 backflip, 540 degrees. At 17,500. Oh my God. Come on.
I've heard a 45-minute or a 45-degree shift. I'd never heard the 540. That's
And so all of this was done by the Russian module that fired, and it flipped it over. What kind of stresses had to be on that thing? They must have been absolutely unimaginable. Oh my God. This is,
they didn't even notice.
This is so moronic. Absolutely so moronic. I can't even believe it. But
people buy it though, don't they?
Yeah, they sure do. They sure do. And then impact of space station spin requires study, official says. Yeah. A glitch that caused it to do a 1.5 backflip. That's a glitch. That thing should have come down in flames.
Oh, give them time, Bob. Give them time.
Yeah, I know.
Still think this thing's going to destroy itself and all mankind into outer space. Just robots will be allowed to go.
Down the article, it says 45 degrees. So we're getting contradicting stories here. Because 45 degrees is much different than 540 degrees.
Well, 1.5 would be, 360 and 180, right?
Yeah,
So,
that's a huge difference from 45 degree shift to doing a backflip.
Yeah, 540, but yeah, whatever. I mean, it's all ridiculous. Come on. The stresses across that thing would have been mind-boggling. And I seriously doubt that would have had enough propulsion. What are we talking about? This is all bullshit. We know it's bullshit. It's not there. It's not real. This is all fantasy. Why are we even treating it like it's real?
It's Narnia. It is Narnia.
It's total Narnia. But, I guess it got us talking, right? But we're talking about how retarded it is.
But there are people out there that are discussing this like it's the fight scene between Luke and Han Solo. There are people out there that, the Star Wars people that really get into that stuff. The NASA nerds really get into this stuff.
Yeah, they want to imagine someone spacewalking out there with their fire extinguisher and correcting this thing just, because they're so skilled.
Yeah.
Firing their fire extinguisher off and, good grief.
Well, John is having problems too. His internet keeps crashing and he is not able to get back on. Why is it that this always happens on this show? This is weird. I don't know if we're being targeted, or what, but, one time I lost our internet. I'm sorry?
I was going to say, I'm surprised Savage is still here. Usually
That's exactly
2 or 3 times during the show.
That's exactly what I was going to say. I can't believe it.
Yeah, it's insane. That's crazy. But, we're obviously, we're battling an uphill battle on all fronts. And, with what's going on in the world today, it's only going to get worse. And, thank God for small little victories like what happened in Canada, but we're going to need a lot more stuff like that to happen for people to really start waking up. And, I think once they realize the magnitude of what's going on, in today's, political climate, then all of a sudden flat earth won't be such a stretch to buy anymore.
No. Well, they always say, it's 10% that change the world, 90% just follow along. And I think we're beyond the 10%, to be honest, but they are trying to convince us that we're just a fringe, out there, small amount of people that are considering all of this stuff. But in terms of what they've done, if 10% of the world hasn't woken up, then we're in a lot of trouble. But I think we're more. I mean, did you know that even by their numbers, 87% of Australia are not vaccinated? 87%.
Wow, that's crazy.
Yeah, isn't it?
That's nuts. Yeah. What do you do? But this is crazy. This really bums me out because this just sucks. This is bogus, but, we'll see what happens. And they better handle this very carefully. That's all I can say. And South Dakota better be a state like that.
Well, I think it's good news. I think it gives him, just like the guy in Canada was given a $1,200 fine or whatever for breaching COVID rules. But he was allowed, given that, he was allowed to bring the evidence to the court. And this is fuel for Austin to take this all the way and show how absolutely illegitimate and illegal, unlawful these people are acting, way beyond their scope. So it's I would think it's a good thing.
Yeah.
As long as they don't.
Well, see, maybe they'll let him out. Maybe they're just detaining him and they'll let him out. I don't know. Who knows what's going to happen? But
I think they will. I think they'll have to.
Yeah, probably. I hope so. Because if not, it just sucks. It really does. But Austin is.
Yeah, I've seen a lot of these. This happens a lot where they refuse to give them their name or identification. They'll get held for 4 hours, 8 hours, sometimes the 24 hours. But they're always released, no charges.
Yeah.
What you really need to do is have a piece of paper on you that says, fine, you can, I understand I'm detained, but here's my prices. Here's my
fee schedule.
My fee schedule.
Yeah.
For every 15 minutes you detain me, it's $100. That's my charge.
Yeah.
So if it's an unlawful detainment, I'll be expecting you to pay this when we're done with this.
I mean, if you're prepared for this sort of thing, then you can seriously take them to the cleaners, and they will quickly realize that as well, and probably usher you out the back door quietly and silently and hope that they never see you again. However, I don't think Austin's probably in the same vein as most people. And not giving your name and your date of birth and everything is the key, absolute key to challenging these people, because you're not a name and you have no personal knowledge of your date of birth.
Yeah.
So it's a game. It's a good game, and I wish Austin the best of luck on this one, because if they push it any further, then he has grounds to take them to the cleaners.
Well, he already does for what happened in Florida, and the attorneys are working on that, because what they did to him there was it was cruel and an unusual punishment, point blank. I mean, that was just absolutely Orwellian what they did to him there.
Yeah, and people are winning these things day in, day out. You'll never see it in the news.
Yep.
Yeah, you know this, Zach. You're watching all the First Amendment audits and that sort of thing. I mean,
over
this
$3 billion of taxpayer money, United States taxpayer money, was paid out due to people's rights being violated.
Yep.
And that was between 2019, I think, and 2020.
Wow.
And what's NASA's budget a day?
Yeah.
Yeah.
That's insane.
Yeah.
All right. Well, anyway, guys, I don't know what else to say about this, but it's a crazy world, and let's just all keep Austin in our prayers. Hopefully he will be released tonight. If not, like I said, as soon as I clean up here, I'm going to call Chris and see if I can do anything from here. And, we'll take care of our guy,
Do we know where he's gone, and can everyone
I think he's in that car. I think he's in that car right there.
Can everyone watching call that station and demand to know what's gone on? We've watched the live stream, and
well, they may have already told us what's going on. I mean, the cops were telling us something, but we didn't watch the whole thing, so I'm going to have to go back and watch it. But actually, I'll just call Chris and see what's going on. But yeah, but I have a feeling he's in this car. I think he's in that car.
Yeah, well, power to you, Austin. We're thinking about you.
Yep. So, all right, guys. Well, let's call it a show then, guys. And everybody, like I said, keep Austin in your prayers, guys. And, I will do the same thing. Can you
stick a link to that in the chat? Or
I absolutely can.
Yeah.
Let me reduce this, and let's see, copy. And let's put it in this chat. Okay, it's in that. It's on the Wits Gets It channel, and I will put it in Rockfin. And paste. There's Rockfin and one for DLive, because we're also broadcasting on DLive tonight. So, all right, there it is in all of them. So,
brilliant. All right, I'll keep an eye on that one.
Okay, cool beans. All right, guys. Well, let's call it a show, and thanks for joining us. It's been kind of interesting. I hope we got our point across about the sun and the EM radiation. And, you know, these impossible distances simply are not possible, not even in the realm of in Narnia. I mean, it's just not possible. And we have so many real-time, real-world demonstrations that prove that. And on the other hand, we have NASA telling us that, oh yeah, we can receive 1/10 trillionth of a billionth of a watt. Give me a break. You know, just not possible. And I really am calling on people with any technical expertise to call it out, because this is bullshit. You know, this is just not happening. And it's ridiculous to even assume that it is. So there you have it. All right, guys. So anything, well, John isn't here, so I guess so much for John. And so John, you John, have anything that you want to talk about, or before we get out of here?
No, I'm all good. I'm just wondering who's filming this and how they're filming it. But
it's Chris.
No, tonight.
Chris is filming
show, it. Chris who?
Chris is the guy that's driving the van. He owns the RV.
Oh, the massive RV. Right, gotcha.
Yep.
Nice one. Because, yeah, this is great. But, yeah, tonight, absolute nail in the coffin, as always.
Beautiful. Well, thank you much for that. Appreciate it. And Zach, what do you got coming up, sir?
Just the usual. Friday, we'll be doing Ironworks in the morning, 5 a.m. Eastern, over there in Iron Realm Media or on TFR Radio. And then Friday evening over on Iron Realm, we'll be having a guest. And that show starts at 6 p.m. Eastern Time.
Beautimous. Okay, that sounds good.
And I think it's her first time coming out and being on a show.
Oh, really?
I forget her name. She's been in a bunch of chats. I've seen her all over the place. I just can't remember her name right this second. I'm sorry. But yeah, it's I don't know. People feel comfortable for some reason going on to IRM first. Maybe it's because we don't get so many people. You know, I like to think it's because we're so nice but yeah, it's a nice jumping off point for people.
Yeah, no doubt.
Not a lot of pressure. There's not, 1,000 people watching.
Yeah. Okay. Well, it's a cool show. I love it, So love listening to you guys talk. And once in a while, I even wake up on Tuesday mornings to listen to it and or Fridays. So that's cool. All right, guys. Well,
V. Thomas Whitsitt gets nicked.
V. Thomas Whitsitt gets it? What?
Whitsitt gets nicked.
Okay.
We need a t-shirt.
Yeah, for sure. We're going to have to come up with a new t-shirt. So these guys are calling one Adam 12 and, all their little cop buddies. And we'll see what happens. Freaking park police, no less. Unbelievable.
Unbelievable. Yeah, unbelievable.
Yep. All right, guys. We will see you on Sunday. And we'll be talking more about what's going on. And especially when we kick over to the Rockfin side. And so if you can, join us, please. And, sign up for the Rockfin. By the way, Eric Dubé just signed up this week, I guess, and is now on Rockfin. And I noticed tonight that I have a new subscriber that signed up under Globebusters. You want to take a guess who that might be?
Reds Rhetoric?
Nope. Eddie Bravo.
Oh, very nice.
Nice.
Yeah, blew me away. I'm like, whoa, Eddie Bravo just subscribed to me. That's awesome, under our channel. So that's really cool.
Good stuff.
Way cool, Junior. So thanks for that, Eddie Bravo. Much appreciated. All right, guys. So we're out of here.
That guy is awesome.
Yeah, definitely. We will see you on Sunday. And until then, be good to each other. Don't lie to each other. Open your mind, because there's truth inside. Peace out, everybody.